So welcome back, Level 2 NCEA Chemists, finishing off the organic compounds external, looking at the carboxylic acids. So in terms of the carboxylic acids, the class name are, of course, the carboxylic acids. The formula is RCOOH, where R can be an alkyl group or a hydrogen. The general formula is CnH2n plus 1 COOH, where N is the number of carbons. The carboxylate group is the functional group, which is essentially the C double bond O OH group you see there in the image, and the suffix for these are the oic acid. So in terms of numbering, very similar to the previous homologous series that we've looked at. So for example, the prefix is basically an indication of a number of carbons. So for example, methanoic acid, methane, 1 carbon, ethanoic acid, ethane, 2 carbons, propanoic acid, propan, therefore 3 carbons, and so on. Okay, so it's quite similar to the previous examples we have looked at in the course. In terms of naming carboxylic acids with different functional groups, again, similar rules to the previous homologous series that we've looked at. So you start with the longest carbon chain, which is attached to the carboxylic acid group. Then you number that carboxylic acid, that carbon that contains the carboxylic acid, with, as 1, and then you number the associated substituents from that smallest value, okay, the lowest value. So for example, looking at the 2 examples here, the top one, 3 carbons is the longest chain, so propan. It's got the oic at the ends, the carboxylic acid group, so it's a propanoic acid. And the carboxylate group is on the first carbon, therefore the methyl group is on the second, so it'll be 2-methyl propanoic acid. And the bottom example, again 3 carbons, so propanoic acid. And if the carbon attached to the double bond OOH is the first carbon, that means that the chlorines are going to be 2,3 dichloro, because you've got 2 of them, propanoic acid. So carboxylic acids, they're acids, so they are indeed acidic. Okay, and they're considered as weak acids because they do not fully dissociate with water. Okay, so it's a partial dissociation. What that means is that in solution, primarily, the acids exist as the protonated carboxylic acid as opposed to the carboxylate ion. The majority of the acid is in the form of the carboxylic acid. A very little bit in solution forms the carboxylate ion and the H3O plus hydronium ion. Okay, that means that this is compared to, say, hydrochloric acid, which is a strong acid, and in that particular case, in hydrochloric acid, it's 100% dissociation. All of the protons in the hydrochloric acid form the hydronium ion 100%. We don't see that with weak acids. So the pH is around about 3 to 5. Okay, in terms of the reactions with the carboxylic acids, they do undergo a number of reactions. So the first one is the reaction of a carboxylic acid plus a metal carbonate gives the associated metal alkanoate. Okay, in this particular case, sodium ethanoate plus water plus carbon dioxide, and that's that carbon dioxide that we see effervescing or bubbling, which is a test to say that we've got a carboxylic acid. Carboxylic acids can also react with strong bases like sodium hydroxide to again make the associated metal salt. In this particular case, when sodium hydroxide uses a base with ethanoic acid, it's sodium ethanoate, and we only get water. No carbon dioxide is formed. I get salt formation, which is the sodium ethanoate. And the final 2 reactions are the reaction with a carboxylic acid with a metal. Okay, it gives the corresponding metal salt, in this particular case sodium ethanoate in the top one and zinc ethanoate in the bottom one when they react with sodium and zinc respectively, ethanoic acid, and hydrogen gas. So again, you'll see bubbling when you react it with a metal, but this time it'll be the gas will be hydrogen, not carbon dioxide like in the previous slide. And the final reaction again is a salt formation. So essentially what happens is that a carboxylic acid reacts with ammonia to form the associated ammonium salt, which is highly soluble. Okay, so that's an example from the real world. That's the reason why you say put vinegar on fish and chips, to get rid of the amine smell, because the salt of the amine, which you get from the ethanoic acid, the vinegar, does not smell.